All right, y'all. So this is the 3-4 enrichment guide. We've done it in class, but for whatever reason, if you are studying right now, you don't quite remember, you can play this video back and hopefully it'll give you some kind of understanding of what to do. So starting off with the question, it gives us the vertices of a square. So those are 4 corners of the square located at A, B, C, and D. And some kind of rotation has happened about the origin. That's going to map B, our original point of B, which is 5, 5, to our point of 5, negative 5. And so it's going to ask us, one, what kind of, or what degree rotation was this? So we can select from 45, 90, 180, 270, 360. And in our selection, we need to first look at what we actually have. So I have a piece of graph paper here. Okay. So of course in a graph we know we end up with 4 quadrants, or at least in what we're studying right now. You get to your upper level maths and you start talking about X, Y, and Z, but we're not there yet. So our original point ended up at 5, 5. So 5, 5 we know to be in this quadrant here, which we call quadrant 1. 5, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the original point of B. What happens is that our new point is going to be 5, negative 5. So count out again, 1, 2, 3, 4, 5. And then we're going down, 1, 2, 3, 4, 5. So in this case, the rotation that happened was just one 90-degree rotation. And we can call that a 90-degree rotation, of course, going clockwise. So we know that it's 90 degrees clockwise. I'm just going to put CW. Another way for us to get to this same point right here is to go counterclockwise. And remember, this is the one time that you can look at the clock to help you decide what you're going to do. So counterclockwise, of course, will be going this way, 90, 180. Down here, we know that it would be 270 degrees counterclockwise. Now, both of these are going to be exactly the same answer. And if you have your notes with you, your notes for rotations, then you should see that notation that 90 degrees clockwise is the same as 90 degrees counterclockwise. What you should also see written there is underneath that, we started off with the X, Y. And underneath that, what you're going to see for the 90 degree clockwise, you should see where you have the Y, in this case, negated. Okay, so remember, even each time we move, we take the numbers, we switch them. So the Y comes to the front, the X goes to the back. And then, of course, in that case, what we see here is that that back number, which was originally the X, is now negated. And this is what you should see in your notes at the bottom of the paper. So anyway, we have that there. And so now all we're going to do is put that this is a 90 degree. So again, we went 90 degrees. And then what happened there is that it was, of course, clockwise. Please remember that I also said that this could be a 270 degree counterclockwise. I'm going to just write that over here on the side. Whichever one you put into the computer will be recognized as long as it matches up. So what do I mean by that? Please, if you're going to put 270, you've got to pick counterclockwise. If you put 270 clockwise, it's going to be incorrect. So please write the counterclockwise for that. And going back to our graph, the next thing that they ask us about is the image of C. So our original point of C is at 1, 1. We're following the same exact rule to get to C prime. So if we go 90 degrees clockwise, we know that our numbers flip and we take the sign of the new quadrant. So we end up here at 1, 1. So if we flip that, we get 1, 1 again. And we know in quadrant 4, the signs that we are going to have is positive, negative. So this is where we're going to be for C prime. So we know that C prime will be 1, comma, negative 1. So now on your assessment, you're going to have 2 blanks like this. What that means is you need to fill in one number here, and you need to fill in your other number here. So this is for your X, and this is for your Y. Okay, and that completes this particular question. I'm going straight to 2C. 2C asks us how many lines of symmetry does a pentagon. I would prefer that this says a regular pentagon have that will reflect it onto itself. And what we learned about our lines of symmetry is that the lines of symmetry for a regular polygon is the same as the number of sides. So I had you make a little note like this in class, that this was the same as the number of sides. This means number, not hashtag. Okay, please. I'll be trying to hashtag my lesson. Okay, so here we go. So a pentagon, of course, looks like this, exactly like this. So we know that it has 5 sides. And so since it has 5 sides, it has 5 sides of symmetry. Please remember your symmetry is going to be the lines that cut this in kind of half, where you can fold it together and kind of make a sandwich. Okay, it can happen going here. It can happen if I spin it and go here, that's 2. Okay, if I spin it and go here, that's 3. Of course, this one is 4, and this last remaining one would be 5. Now, we've done that in the lesson before, so I'm not going to do it on that one so that you're not confused about what we're doing with 3A. Lines of symmetry, done. The next one asks us about a rotation around the center of this here, the center of this. That will map the pentagon onto itself. So I did a lesson for you, and I taped it about finding the central angle. And I told you to find the central angle, which each one of these would be central angles. It's very easy, and I told you that that was step number 1, was to find the central angle. And to do that, you would do the 360 degrees divided by the number of sides, and in this case is 5. And when we do that, we end up with 75. Sorry, ooh, I'm wrong. 72. We end up with 72. Y'all, this 72, we need to go ahead and do something with that. I told you the rotation occurs each time we turn it 72 degrees. So if I was to take this and turn it 72 degrees, I would land right here. The shape will be right on top of each other. So in this case, what I need to do with this 72 is divide each one of my answer choices to see which one I'm actually going to end up with the complete rotation. All of these will be multiple rotations, but some of them will not be completed. So we did 540, which is the first answer choice. That's how many times it was turned, or the degrees that it was turned. Revolutions are rotations. We can use interchangeable. So we'll see that word later, so don't get lost in the sauce. We're going to divide that. Once we hit that up with a division, we end up with 8.88, and I think that continues in our calculator. We do the same thing for 530 and divide it by 72 degrees, and we ended up with the 763, and I think some ones repeating after that. I can't remember, but I think that's what it was. So again, not a complete rotation. We hit that 180 with the 72 degrees, and once we do that, we end up with 2.5. Although this is a clean decimal, it is not a 3 complete rotation or 2 rotations. This is 2 rotations and a half. So this cannot be one of our answers. We test the next one at 680. And divide by 72, and then of course this one ended up with 9 complete rotations. Complete rotations is what we're going to be looking for on our exam on Monday. Okay, complete rotations. If it's not complete, then we can't do it. You'll do the same thing with this one right here, but for the sake of time, be it that it is the weekend, I'm going to keep going. Okay. So I do want you to look over this if you can. If not, then it's cool because you know that the test is Monday. Okay. So here we go. If two polygons are, remember I told you need to memorize this whole thing. Why? Because the blanks are not going to be the same. Similar is the word that we're looking for here. Similar. Then the corresponding, which means the sides that match up. We talked about corresponding before when we talked about parallel lines cut by a transversal. The corresponding sides must be, and the word we're looking for here is proportional, and I most definitely should have made that a bit longer to fit that word in there. And the corresponding, so I'm just going to write it up under here. So the corresponding angles must be congruent. Please, y'all. I went over this in the previous lesson that is videotaped for you on your Teams page, and you should be able to review that to see this broken down. Okay, here is just a sentence, but I would suggest to you to memorize the whole sentence, so no matter what is missing, you're able to fill it in. Remember, in anything that we do, these angles are going to be congruent. That's in everything: dilation, rotation, reflection, and translations. We know that the angle measurements will always be the same. They'll be congruent. Okay, that's enough of that. Let's go ahead and put. I did this one, but I'm going to go to this one to spend the time here. Again, I said that I was going to concentrate on just this part here because this is the part that's going to be assessed. So, of course, when dealing with a dilation, we got to hit it up with whatever our scale factor is, some multiplication. But in this case, they give us a little fake here, and we ended up with coming from the center at 4,2. Y'all, we got to come from 4,2. So before you get started with this, I'd ask that you plot that 4,2. And follow the rules from your dilation notes, okay? Notice how I'm going to be referring back to your notes because that's where I taught it, okay? So the center of dilation, you guys, here it is. We want to find out what is the y coordinate, and here's where we have to be careful on our test. If you put both the x and the y coordinate down, we're going to be in trouble. So let's start off with dealing with point B. Where is point B located? Well, it's located at 6, 8. So let's go ahead and plot that, and then we can run back our notes, okay? 6, 8, y'all. B. Remember I told you you needed to do, I think, 3 steps in this. And step number 1 is that we had to find the distance from the center of dilation to the point for the x and the y. So we're going to do that first. All right. So on the x-axis, from the center to B, I had to travel over 1, 2. Okay. I had to travel over 2. Okay. Remember, step 2 was to multiply that by the scale factor. Well, we can clearly see that the scale factor in this is 1/2. Okay, and of course half of 2 is 1. We do the same thing with the y-axis. And the y-axis we've got to find from, remember again, from the center up to the point. So here we go. We're going up 1, 2, 3, 4, 5, and 6. Okay, that's 6. I'm just going to move my hand so you can see clearly that that's 6. And I'm going to hit this with a 6, just like that. All right. Now that we have that, we're going to write it down right here and multiply it by 1/2. And again, easy math here. We know that half of 6 is going to give us 3. So we've done step 1 and step 2. Remember, step 3 was, of course, to get our new point by simply adding this number and this number to our center. Okay. Remember, we always start off with that. So I'm writing the B coordinates. Now there's a reason why I'm doing both, because on the test they may ask you for the x coordinate or they may ask you for the y coordinate. Okay, so be ye prepared. We hit this 4, 2, which is our center. All right. And for the x-axis, we always write our x first and our y second. We go to our 1, and so we add the 1. We go to our y, and we add the 3. And once we do that, we end up with coordinates of 5, 5. Now, in this case, we get a little lucky because you can really mess this up and put down 5 for your x, and they don't know. So in this case, you want to make sure that you only put one number in the box or on the line or whatever is going to be on the test to make sure that you solve correctly. Okay, and that's it. That's steps 1, 2, and 3, just like that. Y'all, when we get to one like this one here, we want to make sure that we understand that we are matching up triangle ABC with triangle X, Y, Z. So we have to make sure we understand that the X is going to be here. Okay, it's the first letter in the triangle, just like A was the first first letter in the triangle. Y was the second one, and B is the second one. And then, of course, C and Z line up. When we read this, they're telling us they only want the coordinates for X and Z. So to do this, all we're going to do is hit it up with the scale factor. This is when we get lucky. It's just an easy multiplication. So I'm going to do X first, and I know what you're thinking, why. I'm going to do it to show you. 3 over 2, and we're going to multiply that by 0, 0. Now, we know anything times 0 is just going to give us 0. So we know the coordinates for X is going to be 0, 0. Okay? Now, they ask us for Z. Z lines up with C. So since Z lines up with C, we've got to do the 3 over 2 times 4, 0. So we get really lucky here because we end up with another 0, but this first one, we've got to do that math. And what I'm going to do is show you the math first, okay? So we get this 3 times 4. Remember, you multiply across when you multiply. Oh, sorry, let me go back. Y'all know we put that invisible 1 that's always there to make it easier, okay? So we hit that up with the 12. I didn't know my highlighter was going to be bleeding through like that. And then 2 times 1, of course, gives you 2. And then 2 divided into the 12 gives you 6. Slow down. Do your math on this, okay? Don't try to rush it. Now, I know y'all already know that's 0, so I'm not going to take the time to do that. Now, hint, hint, if you divide 2 into 3, you already know that's going to give you a pretty clean decimal, meaning that it's not going to be any running numbers. So if you put that into the calculator, you know you're going to get 1.5. That 1.5 times 4 is definitely going to give you the 6, okay? So it's left up to you how you want to do it, but listen now. You can't do this if your decimal is not going to come out clean. For example, if this is 2/3, you're going to end up with a 0.6666666 repeating. That's not a clean decimal. That will not get you the correct answer. Okay, I'm glad that I was able to share that with you. We're going to continue and go down here to Kendrick Lamar's garden. Now, we talked about this, and we talked about it having a rectangular dimension, and I'm going to use this paper below to draw the original garden and the area that he wishes to compost. Now, I was telling the class what a compost area is, and some of you guys might actually know already, but a compost is just where you take your organic stuff, peelings from your oranges, stuff like that, and leaves, and you kind of pile it up, you know, flip it over every once in a while, and eventually, of course, it turns into dirt. And a lot of people use that for their garden instead of having to go purchase dirt and stuff like that. So that's that story, and it's over. So we know that the dimensions of this is 100 by 150. We know this compost area needs to take up 1/4, which is a rather large amount here, but hey, you know, you got space, you got space. So 1/4 of the area is going to be located just like that. Now, I wanted to draw it on the inside, but I'm going to break these down. The key word to what we're going to use here is similar. And what's going to happen with this similar is that we're going to be hit up with a scale factor. So remember, when we're talking about similarities, the only thing that has that is when we're talking about a dilation. And of course, the dilation that is about to occur here will be a reduction. How do we know? It's less than 1. Okay? All right, so let's hit this up and continue on. I'm dropping some little nuggets in there as we go. Okay, that's everything separated to the best of my non-artistic self. Okay, we got to hit this up. Now, there's 2 ways to do this, but I'm going to do it this way so that you can see it and be mad later. Okay, I'm going to hit this up with a 100, and since this is a dilation or reduction, I need to multiply by the 4th, and we know that from our rules of dilation. Hitting that up with a 4th, we know it's 25. We're going to do the same thing with the 150 and hit it with the 1/4, and then of course that's going to give us 37.5. Okay, comes out clean. So we've got 25 here, and I know that this is going to be 37. The reduction happens on the corresponding side. They are proportional. They are proportional to one another on the corresponding sides. Okay, so now that we have that, we go back to our reading, and it says how much chicken wire will be needed to enclose the compost on all 4 sides. So right now I've got 25 here, and I've got 37.5 here. That's definitely not 4 sides. It's 2. But lucky for us, we know about the rectangle, and we know that opposite sides are congruent, and we use the word congruent in geometry. In elementary school and middle school, you probably just said that they were equal. Okay, so I know that if this is 25, the opposite side is also 25. If this is 37, then I know the opposite side is 37. Take note that I use these measurements here. All right, so for all 4 sides, what we're really truly looking for is what we would call the perimeter, and we add these bad boys up. And once we add all of these up, we are left with 125. That's what we would fill in on our line or type it in or whatever. 125 feet is what we use here. Y'all, we all know the rules of a rectangle. All 4 of the angles are 90 degrees. And we know from our previous statement, I'm just adding this in, y'all. If they're similar to one another, we know that the sides are going to be proportional, but the angles are going to be congruent. So even when we drop this down to this baby rectangle, it's still a rectangle. So those angle measurements are still 90 degrees. Thank you for listening to my TED Talk. Let's go ahead and flip this over to the other side. I'm not doing number 9 just like in class because it is just another one of the number 8 that we just did. In this matching, y'all, listen, don't go through this and be checking everything. Read it and see what the things say before you start checking. Now, remember, we just got finished talking about preserving angle measurements, and I told you somewhere in this recording that all 4 of them will do that. So all 4 gets the check. Okay, when we talk about a congruent transformation, congruent means that it's equal. There's only one thing that happens that's not going to be equal, and that's the dilation. Remember, that gets either bigger or smaller. So big and smaller can't be equal when we talk about the sides. Okay, so we check off the 3 that it applies to. Very good. Same thing with the preserves. Our distance, it's only 3 that does that. Remember, the dilation ends up getting either closer to your point or it gets further away from your point. One of the 2 things happens with the dilation no matter how it's made. We talked about the rigid motion. Rigid motion is going to preserve the distance and also keep a congruent picture, right? It still will preserve the angle measurements, but it has to meet all of the standards. The only one that does not do so is the one that starts with an D. Please notice that rigid has an R as its beginning letter. So does rotation. So does reflection. But there's an R in translation. So he can get a check too. Now that we have that, we're going down to similarity. Remember, similarity is what we did when we performed the dilation. So the only thing that has a similarity is this. Similarity is not the same as being congruent. Congruent is dead up equal. Your similarity is not. That similarity means that they are similar and that they're going to be proportional. Okay, so we've got that non-rigid motion, same thing. It's only one non-rigid motion, which is our dilation, because it grows and it shrinks, getting closer and further away from our rotation. Okay, all right, so we're going right to question number 11, and I'm going to make a little bootleg graph. Y'all, question number 11 on this paper did not give you a multiple choice setting. On the exam, you will have a multiple choice answer, just like that one worksheet that I gave you in class that had the multiple choice. So I'm going to go ahead and plot G. Yes, G. So plotting G. Oh, it's E on my paper and G on this one. Y'all, I'm sorry. Whoa. Okay, let me go with the G on this one, okay? On your paper, it should say E. All right, that's my bad. I made some changes, but not changes in the numbers. 1, 2, 1, 2, 3, 4, 5, 6. I'm going to use E because that's what we use, okay? So right here, y'all, the very first thing that it says is that it needs to have some type of reflection or translation that's going to be X with something, comma, Y, and then with something, then followed by some kind of reflection. So I know the easiest thing for me to reflect over is going to be one of the axes, and we have two. So I can reflect over the Y axis, which is located here. Let me bring that up some just to make that a little better for us. See, I'm stretching this piece of graph paper. I'm going to give y'all a whole piece of graph paper for this test tomorrow, so have fun. Monday. All right, so now that we have this, then we're going to go ahead and figure out how can we get E lined up so that I can easily reflect it over the Y, okay? For me to be able to do that, I want to try to get it to this point right here, okay? I want to try to get right here. This point will put me in striking distance for me to go 2 to the line of reflection here, and then 2 on the other side to the line of reflection. All right. So simple enough. If I take this E and I'm trying to go to this point here, I can see that all I need to do is go out 1. So remember we had that statement of X plus. So right here I'm going to do X plus 1. Then I'm going to make my way up to this point. 1, 2, 3, going up again. That was 1, 3. So Y plus 3. Remember, all I want to do is bring this over to the other side. So if I was to take this and fold it in half, it would just, it's like, hello, hello, hello. And they would touch. Okay? All right. So again, we've got 1, 2. And then 1, 2. We're able to flip over the Y. Okay, so that means that that last little line down here at the bottom where it says blank axis, you're going to fill in Y. Now remember, on the test, this is going to be multiple choice, so you're not going to have to worry about that. Okay, all right. We're going to go on. We're doing number 12, but the second number 12. Okay, so this number 12 here, we're only going to be doing point T. Okay, point T. So what we're trying to do, and this is where you have to be careful on the exam, is pay attention to what number that they are talking about, okay? Ooh, sorry. What letter that they are talking about. In this case, is point T. Point T, we need to go to the origin. Remember, the origin is 0, 0. Please don't forget that. How do we get there? Well, we start with T, and we move on our x-axis first. Remember, x is left to right. And so in order to get to the origin, we need to travel to the left. So we're going to be going 1, 2, 3, 4, 5. 5 to the left, so that's a -5. And then on the y-axis, we're going to be going down 3. So that would be 1, 2, 3, like so. Okay? And that's it. We've made it to 0, 0. That's all you have to do. Okay? For this one here, this is a chart. Again, don't be going through the chart going check, 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 check. No. Okay? That's not what you're supposed to do. Read the directions. It says, given this quarter, R, S, T, Q, identify the coordinates of R prime after performing each of the following transformations. What's the transformations? Here they are. 1, 2, 3, 4, 5. There are 5 transformations, but each one of these transformations is always going to be happening to the original point. So we first need to go to our graph and say, hey, what are the points for R? And when we look at R, we can clearly see, based off of the way the graph is written out, that that is going to be 3, comma, negative 1. Okay? So 3, negative 1 is located right here. The very first thing that they ask us is a 180-degree clockwise rotation around the origin. You can either remember the rule, okay, or if you don't remember the rule, you've got a graph that you can use. So going clockwise, we know that we are going to be going this way. Remember, the clock turns like this. But remember what I said, clockwise and counterclockwise? It's the same, get you to the same point. So 90-degree, 180. We end up right here. So since we know that we're going to be in this quadrant, we know that the signs that we're going to take is going to be negative, comma, positive, right? And since we know that this is going to be negative 3, comma, 1. Remember, you can also follow the rule with that tells you that you're going to have your 2 numbers switched, and they both end up negated. Sorry, they're both negated, not switched. So the x and the y stays the same, but they're both negated. Whew. All right, I almost messed that up, but you know where you can find that written and not off the top of your head? In your notes. Okay. So what we're looking for is the 3, comma, 1. Sorry, negative 3, comma, 1. All right. So then your rule for the reflection over the y equals x, remember this is just the 2 coordinates flipping, okay? That's just the 2 coordinates flipping. And when the 2 coordinates flip, in this case we have 3, comma, negative 1, that means we're going to end up with negative 1, comma, 3. They just flipped. Now, when we have the y equals the negative x, remember what happens here is that they flip and that they both are negated. Now, again, y'all, you can go to the reflection notes to see what I'm talking about if you don't remember off the top of your head, okay? So, flip and negated. So, since they're flipped and both negated, then what we end up with is 1, comma, negative 3. Okay? Now, 90-degree counterclockwise. So remember, counterclockwise is going against the direction of the clock. Here's R. Remember, clockwise is going this way, and we know the counterclockwise against the clock. So when we end up going counterclockwise 90 degrees, we end up in a positive, positive. Remember what happens here, the numbers flip, and we take the signs of the quadrant. So once the numbers flip and take the signs of the quadrant, we should be at 1, comma, 3. Now, reflection over the x-axis, here's the x, okay? A reflection over the x is just going to bring it over to the other side. And again, you can use your notes if you don't remember what happens when we flip something over, or you can use a graph. The beautiful thing about that is, on the x, I just need to travel 1 to get to x. On the other side, I just need to travel 1. And then that's going to give me my point, which is going to be 3, comma, 1. 3, comma, 1. And again, in this one, remember your x stays the same, but your y ends up being negated. Okay, and so that's your rule, and that's the way you can find it with your reflections. So on this chart, that's all you're doing. There should be nothing else filled in except for what they're asking you about on these. Okay. All right. So let's make sure we look at number 14 carefully, y'all. The graph on 14 is bootleg, but please make sure that you have a good understanding of what it is that you're going to be doing. On this graph, you got to run two things. First thing, you got to translate. Second thing you need to do is to do a rotation. But you only have to do it to the letter in which they are talking about. In this case, they're talking about B. We've got to come up with the original point for B first. The original point for B, when we read the graph carefully, is going to be 2, -1. Please make sure that you are dialing and looking into this graph, because, I mean, it is a terrible graph. It is not going to be the point on the test, so you need to make sure that you can read the other 2 points as well. All right, so here we go. B, we've got 2, -1. What we're going to be doing here is adding the 4, because that's our first transformation, and adding the 2. Okay, that's the very first thing they ask us to do. So 4 plus the 2 gives us 6, and then of course the 2 minus the 1 is going to give us 1. Okay, this is not our answer. Why? Because then we got to hit it up with a 190-degree rotation about the origin. One or two things that you can do. Put that bad boy on the graph and hit that 180-degree, or remember what happens. Remember, all that happens is that your x and your y both become negated. Okay, so when we do that, we come from here, and then if we go, it just says 180 degrees clockwise. It doesn't say clockwise. But remember, when it doesn't say, you go counterclockwise, but also remember when it's 180 degrees, it does not matter. You'll still end up in the same place. So going counterclockwise 90, going counterclockwise 180 will land us here. So after doing that 180-degree rotation, we end up at -6, -1. Okay. And the last one, as you can see, is all been the same thing the whole entire time. We need to figure out how to get from one spot to the other to write our translation rule correctly. And again, there's an example in your translation notes where we had to do this. Okay, so starting from any point, and it doesn't matter which one, the point that I'm going to select to start from is going to be point A. Point A is located at 2, -2. Remember, X is located moving from the left to the right. So in this case, in order for me to get to A prime, which is the image, remember this is our pre, to get to our image, then all I need to do is go to the left, and we need to go, of course, to the left until we get there. Okay, so when we count out how many spaces going from 2 out to -4, we see that we end up at -6, okay, because we counted backwards. Now we're going up. Up is positive, so up from -2 up to +1, that means that we're going to end up with +3. When we fill this in, we want to make sure that we include whatever the sign is. We went -6, so please make sure you choose that. And over here, we went +3, just like that. And we are done. Please make sure that you review this if you can. If not, it doesn't matter. Why? Because we did it in class.